In this lesson, we're going to review inequalities, and we're going to use what we learned with that new interval notation, that new code that we have, but we're going to review how to solve, how to graph, and how to use that interval notation, just for basic ones today. So starting off here, remember these symbols. These are your inequality symbols right here. And we want to first figure out true or false. So looking at these numbers, 6 is less than 12, so we say that's true. And over here, negative 6 is less than negative 12. We'll say that one is false. So, how to review what it looks like when we're using those types of symbols. This would be an algebraic way, right here, where you have symbols. And then what are the values for x that make this statement true? This will be our verbal. We'll say x is less than 12. That's our verbal. And then to graph this, we've reviewed open and closed circles. So for this one, it's an open circle at 12. And we said it's less than, so we're going to shade down, 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 down. That's obviously our graphical. And then our numerical would be the interval notation. Where are we coming from? We're starting at negative infinity. So parentheses, negative infinity, comma, 12. Parentheses, because it's also open. So when we talk about graphing or solving inequalities, there's always more than one number, right? There's this whole set of numbers that we're using. Those are all solutions or solution points. It's a set of numbers that makes the inequality true. So let's look at some examples together. How do we solve algebraically? How do we graph? And how do we do interval notation? So for this one here, we could start by distributing the 8. So we'd have 8x minus 40 greater than or equal to 56. And we need to move our 40 over. So we have 8x greater than or equal to 96. And then when we divide by 8, we get x is greater than or equal to 12. That's one way we can do this. The other way we can do this one is to take the 8 and just divide it out in the beginning. We get x minus 5 is greater than or equal to 7. And when we add 5 to both sides, we get x is greater than or equal to 12. So same answer either way. Obviously you don't have to show both, but I want you to be able to see that you can do both ways. So that's our algebraic answer, that's the solving. Graphically, we'll mark a 12. Closed circle, because it can be equal to, and greater than, so all the way up. Interval notation, bracket for 12, up to positive infinity, parenthesis. Let's look at another example. This one here. Let's go ahead and let's distribute the 3. So we'll have 3x minus 15, all of which is greater than negative 2x. And let's get our x's to the same side. So let's move that 3x over. We'll subtract 3x. Now we have negative 5x is less than negative 15. We need to undo the negative 5. So divide by negative 5, divide by negative 5, cancels, so we just have x. A negative over a negative becomes a positive 3, but then watch out for this. Remember, when we divide by a negative down here, like this guy, that means our inequality sign has to flip directions. So make sure that guy flips to go the other way. And this is true not only when we divide, but also when we multiply. Remember, these are inverse operations. They're like sisters. They're really the same thing. One undoes the other. So if we divide or multiply by a negative, you must flip the inequality sign or symbol. You must flip the inequality sign or symbol. So this is our algebraic answer. And then when we come over to graph, we'll have our 3, open circle, greater than, and then our interval notation, 3 to positive infinity. Flipping over to page 15 in your notes, this example here, whoops, sorry. This example here, there we are. We still have our 7. Let's go ahead and distribute that. So we have 7x is greater than or equal to 14 plus 7x. And then we'll subtract our 7x to try to move it over. And we get 0 greater than 14. I know, you're looking at it going, Miss Hanson, there's no more x. You're right. So when the x disappears, sometimes that happens. Sometimes the x's cancel out and we just are left with numbers. When that happens, okay, when all the variables cancel out, something special happens. That means we have two choices. Either the statement that we get is a true statement or it's a false statement. So we want to look at this answer here and figure out, is this true or false? So this one, 0 greater than or equal to 14, that's a false statement. So let's talk about what happens with false statements. When you get a false statement, so for example, 0 greater than or equal to 14, we say that there's no solution. It's not possible that 0 could ever be greater than 14. So when we have a no solution, that's our answer. How do you graph no solution? You just leave an empty line. So this is the same graph for this answer. And then you're probably thinking, well, okay, that's my algebra, that's my graph. How do I use interval notation? Interval notation is this special symbol with the slash. That's no solution. So this one up here, we will say, has no solution, and we won't graph anything. We'll just leave it a blank graph. Sometimes, though, you'll get something that's true. And when you have a true statement, like let's say you have 12 is greater than 5, that's always true. No matter what, 12 is always going to be greater than 5. So we say that the answer is all real numbers. And how do you graph all real numbers? Every single point on this line gets graphed. So we shade the entire thing going both directions. And for interval notation, to show that we've shaded the entire thing, where are we coming from? Negative infinity to positive infinity. So we say negative infinity to positive infinity. That's all reals. All right, let's look at some examples then that use this. So this first one here, let's distribute our 6. So we're going to have 6x minus 13 less than 6x minus 12. And when we subtract our 6x's, we get negative 13 less than negative 12. That statement there, we ask ourselves, wait a second, there's no more variables, all the variables canceled, so it's one of these special cases. Is it true or false? Is negative 12 greater than negative 13? And we say, yes, it is, it's true. But that's not our final answer. Our answer has to be all reals, or all real numbers, which means that we're going to shade in the entire graph, and it means that our interval notation would be negative infinity to infinity. Now, some of you might have gotten some different answers if you tried this problem on your own. Some of you might have gotten answers like 0 is greater than 1, or wait, sorry, not that one. Whoops. Some of you might have gotten 0 is greater than negative 1. That's what you might have gotten. Or some of you might have gotten 0 is greater than 1. And the question is, I know those don't match. That's okay. The question is, are all of these true? So if you're working with a friend, say, and you get this answer and your friend gets one of these, it doesn't matter that your numbers don't match because there's no more x's. What matters is, does your friend's answer also come out to be true, just like your answer came out to be true? That's what matters, because again, the answer is going to be all real numbers. Not any of these guys, but the real numbers is your answer. All right, let's try our second one. Same thing, we'll distribute. So we get 4x minus 12 plus 7 greater than or equal to 4x plus 1. Combine like terms, so 4x minus 5 greater than or equal to 4x plus 1. Subtract our 4x's, so they're going to cancel out. We get negative 5 greater than or equal to 1. Again, check. There's no more variables, so is it a true or a false statement? This one, negative 5, that is not greater than 1. So we say this is false. So our answer is going to be no solution, circle with a slash. And for the graph, go ahead and put a box around it so that I know it's not like, oh, we forgot to graph it. We know there is no graph. It should be empty because it's a false statement. So that's our review of inequalities, learning how to solve it on the side, learning how to graph it, and also learning how to do the interval notation. And we had our two special cases. Two special cases are when the variables cancel out. We get these true and false statements, the all reals, the no solutions. You can have answers where you do have an x still left in here, in which case you just graph it like normal, and you use your interval notation like normal.